Good morning, everyone. I hope everyone is doing well this morning and feeling somewhat refreshed after getting some rest last night. Today, we're going to be looking at Investigation 9 in your books. It is on page 616. We are going to be doing something a little bit different today. I want to go through this investigation with you. This was actually kind of a longer investigation. There were 8 different graphs that they go over in the book, but I'm going to cut it in half and go over only 4 with you today. Also, there's not going to be any additional work to this lesson today. I want you just to follow along with me and keep notes, and I'm going to just give you a grade based on how well you take notes today. So whatever I write, you write, and you're going to do just fine. I'll have you submit the lesson to me today through Edmodo when we're finished, and there'll be no additional problems. So life should be good. Okay, so let's go ahead and get started on Investigation 9. Alrighty, so we have talked about functions in the past. This is not going to be your first exposure to functions. Today we're going to just be going one step further though, because what you have not seen is how we can display as a graph. We can take a function and display it as a graph on a coordinate plane. And so that's what we're going to be working on today. So let's go ahead and start by looking at Roman numeral 1. You notice that there is a function table there. We've already kind of discussed functions in the past, where we have seen where you have, turn on my pencil here, where you have a function given here. In this case, it's y equals x plus 1. And then you have your function table, which is this right here. And you notice here that we have these values for x, and each one of those x's will be placed into the equation or the function, and it will spit out an answer for y. So number 1 down here, that's exactly what they want us to do, is to complete the chart. So let's go ahead and solve for y on each one of these. So we would write out here y equals, and let's go ahead and put in 0 for x, and we add 1, and we end up getting 1. So when x is 0, y becomes 1. What happens when we put a 1 in for x? We end up with 2 for y. What happens when we put a 2 in for x? Well, then y becomes 3. And then finally on the last one, if I put 3 in for x and I add 1, I end up with 4. So there's my y values when x is a certain number. Whoops, I did not mean to erase all of that. Let's put those right back in there. Okay, so now we have completed the table. So that now, number 2, we can take our x and y values and we can rewrite those in this third column. This is new. This is not something that you've seen before. So this is what we're going to do with our x and y values in our function table. Those particular values now become coordinates, and we're going to be able to plot this equation up here, or this function. Whoa, did not mean for that to happen. Sorry, guys. That make you dizzy? We can take and we can plot on our coordinate plane this particular function. So over here, let's go ahead onto our graph. I want you guys to go ahead and fill in some numbers here for our graph. We only really need to go to 5 and -5. Positives up here and negatives down this way. And let's go ahead and plot those points. So we had 0, 1. We had 1, 2. We had 2, 3. And we have 3, 4. If you have a ruler handy, can you grab that? If you want to pause the video to go find one, that would be fine. If not, maybe you can use the edge of a paper or your book or something, but you're going to want to make sure that your line is drawn nice and straight. I tried to do it on my iPad with a ruler and it doesn't work out for me, so I can't do it, but I'm going to try to draw as straight of a line as I can. So number 3 down here wants us to connect the points to make a line. So let's go ahead and try that. Okay, Mine is not very pretty, but yours probably is beautiful. Up in the first quadrant here, we're going to go ahead and write the function that we just graphed. We always do that. Write that into your graph. Okay, so there's our line. And you notice that when I graphed each one of these coordinates, I can connect them and make a straight line that will go on and on forever. I could test a whole bunch of other numbers over here. I could continue down here with a 4, 5, 6. I could use negative numbers. But in this case, we only needed enough points to plot. Actually, you only need 2 points to plot a line. In this case, they gave us 4. Okay, so the next thing that we want to look at is number 4. I'm going to tell you that A happens to be, there's a point A on the line, and it is at, let's see, oh, phooey. Sorry about that, guys. Okay. Right here. Why is that not cooperating with me? There we go. Okay. Right there is point A. Build that onto your graph as well. And number 4 is asking a question about point A. Point A is a point on the line. What are the coordinates of point A? So see what you figure those to be. Looks to me like they're -2, -1. Fill that into 4A. And 4B asks, does this set of points satisfy the equation y equals x plus 1? So what we're being asked here is, okay, it looks like point A is sitting at -2, -1, but we want to prove that that actually does satisfy this equation. So we're simply going to take this y equals x plus 1, and we're going to plug these values in for x and y. So let's go ahead and we have y equals -2 plus 1. And what is -2 plus 1? It's -1. So y equals -1. Is that what we said happens? So when x is 2, y is -1. So yes, those points do satisfy the equation. Okay, number 5, we want to select another point on the graph and determine its coordinates. So now you're going to look at this line and you're going to determine where it looks like the line is passing through. So I see a couple of places. It looks like here, looks like here, looks like here. If I had this drawn better, it would look like one here, right? So you can see that it appears that the line is passing through where these points I'm drawing in are placed. But I can't trust that. Like, for example, let's just look at this one. I'm going to test that. My line looks terrible. It's not actually passing through there. I think if I'd have done a better job of drawing it, it would have looked as though it would have been passing through there. But we want to test that because in math, we can't just assume it, remember? We need to test it. So look at number 5. I'm going to take this point. You can choose another one on the line, not the 4 that we used up here. Okay, find another point on the line, like maybe one of these 2 or 3. Or you can just use the one that I'm going to use. I'm going to use this one right down here that I picked. Okay, and we're going to test it to see if in fact it is on that line. All right, so it looks like I'm selecting the one that is at -3, -2. So I'm going to put that right here. -3, -2, and then over here for number 6, they want me to go off to the right, and I'm going to test that. So I'm using the same, we're still on this graph on number 1, so y equals x plus 1. So let's take the x coordinate and put that in for x, and see what do I get here. So y equals -2, which in fact is the y coordinate in my set of coordinate points there. So yes, it does satisfy the function. So we've completed 1 through 7 for number 1. Okay, so that's number 1. Let's go to Roman numeral 2. We have a new function down here, y equals y equals 1/2 times x minus 1. This is beautiful. They already have our table's all filled out for us. They just want us on number 1 to graph the 3 pairs of numbers on the coordinate plane. So we're going to do the same thing. We're going to label our graph here, just giving it about 5. That's all you're going to need. And let's go ahead and graph those points. So we have 0, -1. We have 2, 0. We have 4, 1. Okay, so we've graphed them. Now we're going to connect the points to make a straight line. You're going to use your ruler. I'm going to try to do it freehand as best as I can. Here we go. Don't forget to label in quadrant 1. This is the function we are graphing. Y equals 1/2 x minus 1. Okay, so we've connected our points. What is another pair of numbers that satisfy the function? So we're going to do the same thing that we did like we did in green in number 1. I'm going to come down here and see what looks like it's resting on the graph here. It looks like this one here looks to be on my line. So I guess I'll just choose that one. We'll go -2, -2, and we need to test it. So I'm going to go up here and test it in green. I have a little bit more room beside the function table. So y equals 1/2, and I'm going to use the x value -2, multiply it. I'm going to put it over 1. Okay, but I'm filling that in for x. And then subtracting 1. So y equals, let's see, this is going to be -1 minus 1. Y equals -2, which happens to be our y value. So yes, the function does actually the set of coordinate points does satisfy the function. So we're good with that. All right, number 4, can we find a set of coordinates that include a -x and a positive y? So what does that mean? Well, we notice that, like, look at our points up in the function table up here. We don't have any negative x's paired with a positive y, but let's just test something. Let's see if we could do that. Let's just say I have negative, I'll just keep it in green. Okay, let's say I choose, I'm just going to pull this out of thin air, -4 and a +2. We might even try, I don't know, -3, 4. We could try both of those. So let's go over to our graph and put those on. Let's see where those land. So if I have -4, 2, just watch me. You don't necessarily have to do this. Well, you could do it in another color, I suppose. But I don't want you to get mixed up as to what we're doing here. Just want you to watch. So -3, 4. Notice where those are. Those are in quadrant 2. Well, our line is not falling through quadrant 2 at all. So no, I think no matter what negative and positive numbers I pick here, I cannot have a -x and a positive y. It's just not going to happen. That's going to put us up in quadrant 2 all the time, and our line is never going to pass through quadrant 2. So the answer to number 4 would be no. Okay, let's move on down to number 3. Now we're going to take a real life example here, and we're going to actually see how we can make a comparison and look at a relationship between the length of a side of a square and the perimeter of a square. And we're going to graph the function of it and see how it turns out. Let me grab my blue pencil. Okay, so number 1, first of all, let's just start with getting some information down, then we'll talk about the graph in just a moment. So number 1, we're going to write the formula for the perimeter of a square on the line above the function table. So right on this line here, we want to write the formula for the perimeter of a square. So perimeter of a square equals what? Well, we know if it's a square, all sides are equal, right? So if I multiplied one side length by 4, wouldn't that give me the perimeter? So there is our formula for the perimeter of a square. Number 1 is done. The graph of this function, we can't answer number 2 until we actually graph this. Okay, so we have our function table right here. We're going to graph 1, 4, 2, 8, and 3, 12. Remember, these are our coordinate points. So if I were to put like parentheses around them with little commas, there's our sets of coordinate points, and we can go ahead and plot those. Now, let's talk about this graph, because this graph looks funny. We only see one quadrant here. This is quadrant 1 up here, okay? And that's, excuse me, that is because we have all positive points here. We have a positive 1 and a positive 4. All of our X and Y coordinates happen to be positive. So we know that they're all going to land in quadrant 1. So we are only going to focus on that quadrant, and that is why that's all that's given to you here. So let's go ahead and plot these. We have, oh, and let me just cover this with you. We're not going to call this X and Y. We're actually going to, because this is a real life example, we're actually going to name these according to what they represent in our problem. So the bottom here is going to represent the length of a side of a square. So we're just going to call that axis S. And then this axis, which would normally be our y-axis, is representing the perimeter of the square. And so we're going to call that P. That axis will be named P. Okay, and then this part up here, this is just the title of what our graph is representing. So let's go ahead and put some numbers on our graph here. Now you'll notice that our perimeter axis does go kind of high. We see 12, so we're going to have to label a little bit higher there than we are on the bottom. But let's go ahead and mark 1, 2, 3, 4, 5 across the bottom. And then on the top, go at least up to the 12. Okay, and we'll go ahead and plot those points now. So we have 1, 4, we have 2, 8, and we have 3, 12. Okay, and take your ruler. You're going to start, actually, this is going to come down, and it's going to end right there at the origin. And what is the origin, by the way? That's going to be a question in just a moment, so think about that. Okay, so draw your line. This is going to be a little bit harder for me. Shrink it for a minute. Maybe that'll make it easier. Ooh, that's bad. That's a bad line. It's not straight at all. Yours will be nice because you're using a ruler. Okay, so think about this. This is going to end right here. We're talking about the side lengths of a square and the perimeter of a square. If it were to continue down in this direction, we're heading into quadrant 3, which is has a negative in the quadrant. Well, do any of our side lengths in a square ever have a negative length? No, they don't. So that is going to stop right there. It is not going to continue down this way. That's not correct. Okay, so we're actually stopping right here at 0, 0. All right, so what do you call this in geometry? This is not a line. What is that called? Number 2, we're going to answer that. It's not a line. It actually looks like that. You remember what that's called? That's a ray. Okay, why do you think it's not a line? And I just explained that a moment ago, because a square never has a negative length on any side. So let's write that in here. Oops. A square never ever has a negative length on any side. And what are the coordinates of the endpoint of the ray? I asked you that just a moment ago. I wanted you to think about that. It's at the point of origin, and we say that's at 0, 0. Okay, so that's basically how we plot the relationship between the length of a side of a square and the perimeter of the square. Notice what's happening with it. It shows that as your side increases by 1 unit, your perimeter increases steadily. You can see the pace is a pretty steady pace, inclining in a positive direction. It's going, your perimeter gets larger as your side lengths get larger. In fact, it looks like you're actually going to go, your perimeter is going to increase by 4 each time your side length increases by 1. Okay, so you can see that relationship in the graph as well. All right, and then on our last graph here, again, we're going to have our, oh, hold on 1 second. Do we need to put that in there? We still should write, we still should write here, perimeter equals 4s. That is the function that we just showed right there. Okay, so on Roman numeral number 4, this is going to be a slightly different and kind of interesting and fun graph that we're going to be doing here. So let's read it. Number 4, the graph of a function may be a curve. Below, we're going to look at a graph which represents the relationship between the length of a side of a square and the area of a square. So number 1 says, write the formula for the area of a square on the line above the function table. Of course, there's no line up there, so you can draw one. We want to put that information up there. What is the area of a square? How do we find that? If I asked you how to find the area, you should tell me that you would multiply length times width. Yes, that is true. So, but we're going to refer to each side as S, side. So what do I do with each side for area? If you had a square that had a side length of 2 units, what would you do with that 2 in order to tell me the area of that? Yes, you might go 2 times 2 because you know that each side is 2. But what is 2 times 2? It's not just 4, right? It is 4, but we can express it this way as well, 2 squared. So we could take the side and we could square it. So we're going to use that formula for this particular problem. So write that above your function table there. All right, now I notice that we have some fractions here in the top part of our function table. We have 1/2. So when I put 1/2, and we're going to kind of test this out. So let's write off to the side here. When my side is 1/2 squared, then my area is 1/4. When my side length is 1 squared, then my area is 1. When my when my side length is 2 squared, then my area is 4. And when my side length is 3 squared, then my area is 9. Okay, so we were able to write the formula and complete the table. Now we want to graph these 4 pairs of coordinate points. So let's go on over there and do that. We're going to label this bottom part a little bit differently. First of all, notice that this is the length of the side. This is our area over here. So we're going to call our axes S and A. And we're going to label our sides because we need to make an account for that 1/2, the fractional coordinate points up there. We want this to be 1/2 right here. You don't have to write that, but I want you to write 1. We're going to skip a space, 2, skip a space, 3, skip a space, 4, skip a space, 5. Okay, and then the ones that are on the axis here that would normally be our y-axis, we're just going to label it as 1, 2, 3, 4, 5, 6, and up to 9, at least up to 9. I'll go up to 10. Okay. And let's go ahead and get our points plotted. If you're a little bit confused on how to do that, follow me. Okay, so here's 0, 0. At this point, we're going to start right there. We're going to go over half. This is half, right? Because 1 is over here. So this is half right here. But I need to go up 1/4. So this is 1 whole unit this way. So I'm going to go over and up 1/4. So that point's about right there. The second one is 1, 1. That is here. The next one is 2, 4, which is here. The next one is 3, 9, which is here. Okay, now this is a little bit trickier for me to graph. It's not a straight line. You're not going to need to use your ruler here. You're going to start down here at the point of origin, 0, 0, and you're going to take your pencil and you're going to connect your dots. But you can see what's happening here. You're getting a curve, and mine didn't turn out very pretty. Try that a little bit differently. Okay, see how that's curving? And it actually, the next one would be, if I had a 4, we'd be at 416, would be way up here somewhere. So that baby's going way up in here. Okay, but it's curving. It's a line that is curving. And you can see that. It's not a ray because it's not a straight line. It's just a curve. Okay, let's see. So that's about it. So you've been successful today at making 4 different coordinate plane graphs here. Please make sure also that you write here, what did we just graph? We graphed the area equals side squared, and that's what it turns out to look like. Okay, so that's basically the lesson for today. You will see in tomorrow's lesson, one of these problems does occur from investigation 9. You're going to have to plot something. The cool thing about graphing is, you know, it's a way for someone to, at a glance, kind of see the relationship between 2 different things that are going on. One of the graphs that I chose not to use in here because I wanted to kind of get some of the basics down, but one of them was they were comparing the distance that somebody is running in a certain amount of time. And you can actually plot a relationship between those 2 events, time and distance. And you can look on a graph and you can make the comparison of that sort of a function as well. So they do use these in real life situations. This is going to be posted on Edmodo. I'll put my handwritten notes up there. It'll look a little bit nicer for you. Please make sure though that if you missed anything, you go back and fill in your notes. When you have finished them, upload those to Edmodo. I am grading simply for how well you took notes today. There's no additional problems. I will meet with you on Zoom, however. If you want to go over your test together, we can take the time to do that. Maybe we won't need too much time. I will also be available for office hours at 8 o'clock. So if you need any assistance, you can meet me at 8 a.m. there. Otherwise, I will see you as a class on a Zoom call at 9:15. Please bring any questions. We can go over any problems that you have. I sent your corrections back. If you don't understand why any of those are wrong, we can go over those. So this is going to be your time to get questions answered. If there's nothing, then there will be nothing. That pretty much concludes the lesson today, guys. I'll see you soon. Have a great day.